All right, welcome everyone. Where are we now? Just after lunch. So hopefully this is something that entertains you versus helps you fall asleep, which is what everyone probably says. I've got a countdown clock in front of me. We've got 45 minutes. It normally goes for about 30 minutes. I'm going to do probably a few more demos than I normally do. So I've got about 10 to 15 minutes of slides. And then I'm going to show you what, or how at least Snyk looks at secure DevOps. Sometimes I say secure DevOps at scale, but here in this talk, we're saying that here is my code, secure it for me on the way to the cloud, right? So when we think of app security at Snyk, we're talking about developer security. That means that we're embedding security in the developer's workflow itself. So my name is Pas. I work for this company called Snyk. Some people say, how do you pronounce that? And I've just said it, Snyk. So the easiest way to work it out is sneakers, Snyk, right? So what it stands for is so now you know, so SNYK, so now you know, right? That's actually the truth. It's not a made up thing. So before we get started, I've been at Snyk now for about 18 months, working across customers in the ANZ and also APJ region, so outside of Australia and New Zealand as well. And I always see one consistent theme across all our customers. How do I get the developers to actually start taking ownership of security without affecting their developer productivity, right? That's key. So we're almost looking for a frictionless process. And you'll see from what I'm going to talk about in today's talk and the demos that everything that I'm showing is what developers want to be seeing and where they want to be fixing and what remediation advice they get that then turns into real fixes, right? Because if they just get a bunch of issues, the likelihood of them going to action them is almost impossible, right? So we need to give them remediation advice and give them the right context so they can fix these issues quickly. So I want to kind of set the scene on AppSec itself, right? So, because security is quite a broad topic. So from a Snyk perspective, we look at it from 5 different pillars. And the first one is open source. So as you can imagine, if you're building an API or a web app, what that really means is that you want to write some business logic that has been dictated by your organization. But what you don't want to do is write low-level code that's already been implemented by someone else. And so that's the power of the open source community and open source libraries. And it's supported across many different frameworks and in many different languages. But ultimately, when you're doing that, you're dragging in someone else's code into your IP, if you like. So as a result of that, because it's great, it's in the community, it's open standards, and you can rely on that, you become susceptible to actual vulnerabilities themselves. So someone needs to scan those and determine what they are. The classic one is the log4j vulnerability that actually appeared, the 0-day vulnerability. So as you can imagine, some people were embedding log4j as an open source library. Others didn't even know. They were just using some sort of Spring Boot starter or some other library, and that was automatically including log4j. So I'm going to show you in the demo that we do today. It's an actually Spring Boot app that uses log4j. I'm going to show you how you can surface that within a container, within Kubernetes, and then also show you how you can fix that in an IDE and also fix it in GitHub. So we're going to look at many different integration points. The next one, because it really is about containers, is the ability to scan a container. When most people think of scanning a container, they think of, I need to scan this container and I need to understand what vulnerabilities exist in this container. And that's true. That is what we refer to as the base image that you're using for your container, what vulnerabilities exist. But this is twofold now. I've spoken to you about open source. When you build an application container, typically it's a stateless app. It could be stateful, it could be Redis, Elastic or something like that. But typically it's a stateless app. But what's in there is your open source artifacts and your application components to be able to run your app. So all of a sudden now, your container that's been built from your application code actually has open source vulnerabilities and container vulnerabilities in it. So it's now 2 different attack surfaces. And as we move further down the stack, infrastructure as code, if I'm deploying this container, the standard is Kubernetes when it comes to container orchestrators. If I'm deploying it on Kubernetes, I need to make decisions as to what that deployment looks like. And so from an IAC perspective, we need to be able to scan for security misconfigurations. That's across Kubernetes, ARM if you're using Microsoft, CloudFormation, Terraform if you're doing true IAC in terms of multi-cloud. To be able to use any cloud. And we do that as well. But the 4th one is code. Now, I spoke about using those open source libraries, but ultimately if you're building a billing API or a web API, you need to write some code. And that code is then also vulnerable in terms of security as well. We call that security application, SAST. So in the context of Snyk, it's Snyk code, right? So what that really means is we're looking for SQL injections, cross-site scripting, and other top 10 OWASP vulnerabilities that you're bringing in with the code that you're writing. Sometimes you don't even know that you're doing something that inadvertently could affect the business. But it's our job at Snyk to tell you exactly what the problem is, the remediation advice, and how to fix it. We're going to see that in the demo as well. Last but not least is cloud security posture, sometimes referred to as CSPM. Now, this one's probably the most interesting one, because what you want to do here is you want to scan your cloud and get a viewpoint of what it looks like from a security misconfiguration perspective. But then how do you tie that back into what the developers are doing from their IAC template files, for example? How do you then give them the remediation to be able to say, well, this is what you need to do to fix this, and we're going to block unless you do this, for example. So that's where the Cloud Security Posture Manager gives you that tie-in from a developer perspective. So hopefully what I've explained here is highlighting the fact that the developers are now starting to take ownership versus the security team doing all this late testing after the app's already made its way into production. All right, so what I wanted to highlight on this slide is, and pre-cloud, cloud, just I wouldn't even bother looking at it, right? Because it's come up in every DevOps talk everywhere. But what I'm trying to say here is that now the developer has far more ownership than what they had before, right? Developer, engineer, depends on what you want to call them. Previously, they were just using open source and they were writing code, but now the developers are using IAC. They're actually writing the Docker file that actually creates the container. So now they're starting to pay the infrastructure that then supports the running of the app itself. So as a result of that, it's a shrinking IT ops role. Sure, they'll still want to know what's happening in the cloud or what's happening in terms of what's running on-prem, but the developers are taking more ownership. So what does that mean? That means that there are multiple different configuration files that we need to scan. Not just the code, the open source files, we need to scan the IAC templates that are being used. And we also need to scan the Docker file. So in this actual presentation, we're going to focus on container end-to-end from source code all the way to Kubernetes, and show you all the different integration points and the remediation advice, as well as go and fix these issues live in the demo itself as well. So how do we do it? And in order to do that, we kind of need to live in 4 different spaces here. And then we make it as simplistic as this, because ultimately when we look at DevOps, we know that the developers are writing actual code in their IDE. So we're going to be able to find and fix issues there. Well before they've committed or done a pull request or merge code back into the main branch, we want to go and give them remediation advice there. The code repository is also interesting because ultimately when it makes its way into the repo, which is the source of truth, we want to constantly keep scanning that over time and see what's being fixed, what zero-day vulnerabilities are appearing, and a viewpoint of what's happening across all your different repos that make up your applications themselves. So from an integration perspective on source code management, this is a great way for the business, the security team, and the developers to all get an understanding of what's happening from an AppSec perspective. Because if we go back and shift far left to when the developer was in the IDE, only he knows what AppSec issues he has. And we want him fixing it there as well. But at the same time, we want to be scanning the code repositories as well. So, and when we're integrated into SCM, the real cool thing about this is Snyk can then go and create pull requests, because we've already integrated into the source code management. So we'll go, and every time a new vulnerability appears and there's a fix, we'll go and create a pull request. So that leaves the developer to go and merge and, test and merge the actual fix in. So we've already done the hard work. You may wonder, what is the hard work? We're changing a dependency from one version to another. So if we look at, let's pretend Log4j had, version 1 to version 10, and there was a vulnerability in version 2. A lot of the open source security tools will actually change the version to 10 so it gets rid of that vulnerability. That's a tick. I'll tell you where the biggest problem with that is. The developer more often than not may need to refactor the code because the version 2 of that library versus the version 10 has changed dramatically. So you'll probably need to refactor it. This is where developer productivity doesn't work. All of a sudden, he becomes a bottleneck and he won't want to do it. So if he just goes from version 1 to 2 that fixes the problem, then it's going to be a lot easier for him to roll that fix through. And the other thing that's important there is that every time we say what the fix is and create a pull request, we will not change to that new version unless 0 new vulnerabilities come in. So there's no point in fixing a vulnerability if 5 new ones are going to come in, right? So that's really, really critical. So the smarts of any open source security scanning capability is to pick the right version to the closest version that you're at without bringing any new vulnerabilities in. And that's easier said than done, right? So it's not a simple thing. The next one is CI/CD. Clearly, you want to be able to scan while you're actually within your pipeline. And you want to be able to create security gates or block developers from actually pushing code into production. The classic example is, I don't want to block a developer who's got some container issues that are at low or medium, right, in terms of the security vulnerability posture. But I do want to block if they're critical. And so that will force the developer to go back and fix something. But what I was explaining before, they could have fixed that when they were in their IDE or directly in the SCM at that point, even before they went into the actual pipeline itself. So the ability to be able to scan in a CI/CD tool is critical in terms of releasing secure software. So I'm going to do that in the demo. I'm going to use something called Argo CD, and I'm going to run a scan within Argo CD that will check the IAC config, because Argo CD is more of a CD type of tooling versus a CI. But ultimately, you want to be able to scan there for all the different files that I spoke about. And last but not least, we're in production, we're in Kubernetes. No vulnerabilities today, but 10, 20 days later, there's probably a new 0-day vulnerability. We need to know about it. We need to know every container image that needs to be fixed that will roll that log4j issue fix into the containers as well, because you may have multiple that have got this. And then we want to be able to create the pull request automatically for them. And that's what happened with our customers. When the log4j issue came out, 24 hours later, there was a fix. Actually, it was probably sooner than that. They woke up the next morning, a bunch of pull requests sitting there to go and fix all the log4j issues. And then they could do a search across that CVE and they could say, right, not only do we have these 20 different repos, we also have 50 running containers that are using this log4j vulnerable library as well. So all these things are viewpoints into understanding how they can get the security posture back to where it should be. So with Snyk, we've got this thing called a monitor, which is constantly, so it's not an agent, it's just a pod running in Kubernetes that's constantly looking for workloads as they hit the cluster, as they come on, or they get deleted from the cluster, and we're automatically scanning, and we're scanning daily from then on in, right? That's why they were able to see this log4j vulnerability is ultimately, when they first deployed, it wasn't there, but over time it appeared. So we do this across 4 different products. So Snyk Code, open source, container, IAC, and cloud. But what's interesting is in this talk, we're going to be focusing on container. But when we think of container, we actually should be thinking of code and open source, because that's what makes its way into the container. Your compiled code makes its way into the container, so it's vulnerable from that perspective. Your open source libraries make their way into the container, so it's vulnerable from that perspective. The container image that you choose may have multiple different vulnerabilities, so it's vulnerable from that perspective. How you've deployed it on Kubernetes can also give you security misconfigurations and also make you vulnerable. And then your cloud posture itself, what is happening in terms of what the developer's saying and what's actually happening in the cloud, really, really important. Sometimes referred to as drift, but I prefer to see it as giving the developer context in their config files versus what's in the cloud, right, versus drift itself, right? Because ultimately anyone can go to AWS console or Azure and just make some changes, right? All right, so here's a couple of screenshots to make sure how we're going with time. So we've got 30 minutes, so it's going to be a pretty lengthy demo. So here I'm just going to be showing you, I'm going to show you the SCM integration with GitHub for this app. And I'm also going to show you how a developer can run a scan within their IDE as well. So we'll start there. But ultimately what we want to do is rely on a couple of Snyk's plugins for the IDEs, the CLI, and our integration into GitHub. We actually integrate into all source code management systems. So that's Bitbucket, GitLab, and obviously GitHub as well, and many others. And we also integrate, whether it's public or private, in terms of your source code management system, we can integrate into both. So some of our largest customers have private source code management. They're not going to be putting stuff on public GitHub. So as a result of that, we need to connect into those securely and safely, because we're a cloud platform. We don't install anything on your software to be able to do what we need to, but we need to get access to the source code management system. So we'll see that live in the demo as well. So when it comes to containers, because we kind of want to focus a bit more on containers than anything else here, there's 3 different scans that we do. We scan the Docker file. It's really easy to scan a Docker file because it's an instruction file, it's a text file. It tells me exactly what base image I want to use. It tells me exactly what libraries I've added, any user instructions are there. It's all there for me to see. But the good thing about a Docker file is it's in the repo. The container's not in the repo, just the Docker file. So I can make fixes to the Docker file before we even go and create the container and push it into a registry. The next part of that integration is connecting into a container registry to do the same or similar type scan. The difference this time is we are auto-detecting that base image, because an OCI image is just a tar. Basically, a container registry is just a dumb blob store. All it does is hold a bunch of containers and are sitting in that registry, and not all of them are running in production anyway. But when we scan there, we want to be able to do two types of scan. One to scan against what the base image is that we need to auto-detect, and the other one what open source components are inside that container and give you a viewpoint of both. So you'll see in the demo when we scan at the Kubernetes level, or even when we scan at the container registry level, that we will provide you individual scan types with remediation across both open source and the base images as well. And last but not least, we want to be able to scan what we call running workloads in the Kubernetes cluster. So we've got version 1 of an app, we go to version 2, we want to drop version 1, version 2, load it into Snyk and have a look at what it looks like. Or we've got a billing API, now we've got some other API, I don't know, a customer API, for example, and that makes its way into the cluster. We need to automatically import that and monitor. We want to do it with zero clicking, zero intervention. We just want to make sure that we pick up the running containers in the Kubernetes cluster. And that's what we do with Snyk. It's called our Snyk controller. That Snyk controller's job is simply there to scan containers as they hit the Kubernetes cluster and remove them once they're gone, right? And then we can get that viewpoint of what's happening. I'm working with a large organization at the moment who wants to do one other type of container scan. So you may think that they're the three types, but there's another, right? So you can actually build a container and actually just build the tar file itself, right? So there are tools and utilities that do that. And that's the simplest way to build a container so you can see what it's going to look like from a file system perspective. They want to be able to scan that itself. So we also provide the ability to scan a container that you can do a Docker save and get the container onto the file system, but you can also create a container on the file system as a tar, and they want to be able to scan that before they tag it and add it to a container registry. So we can do that as well. I don't know, there's that many different CI/CD tools. Just this one here is Azure DevOps. I'm not going to say it's my favorite, but it's just easy to use, right? So when I say easy to use, there's a whole heap of plugins that I can select from. And Snyk's one of those, right? But ultimately, in the demo that I'm going to show you today, I'm going to show you running 4 different types of scan in Azure DevOps across open source, code, container, and IAC, right? So we can block across all 4 of those before this Azure DevOps pipeline can even get an app out into production or update an app in production itself. And you're going to see through some of the utilities how we can get HTML reports, JSON reports, how we can see what we need to see in Snyk app. And that's all possible through some of the utilities that we have itself. So if I look at this screen here, what I'm doing here is, as I'm running scans in the Azure DevOps pipelines, I'm creating artifacts and I'm attaching those artifacts to the Azure DevOps pipeline run. And so as a result of that, I can then get a viewpoint of exactly what's happening when this pipeline ran in terms of how many security vulnerabilities we had and all the remediation advice. Now remember that anytime a pipeline kicks off is you've made a change to something, right? And so as a result of that, you actually want to go and package the application and deploy it. So we're already connecting into source code management with GitHub anyway. So we're already connecting and running that there. This is just another way of gating in terms of stopping apps from making their way to production that are vulnerable across the different types of scans that we can do. And the last part of this demo that I'm going to do, I'm going to actually, you can use Harness, you can use Argo CD. There's many different types of tools. I'm going to use Argo CD here to deploy this Snyk Boot web app. And from the moment it deploys, it's going to automatically make its way into Snyk app, and we're going to then start seeing exactly what vulnerabilities we have on an app. But before we do that, we're going to go all the way back to the IDE to see what they are, even though we haven't yet deployed the app as well. So we're going to go end to end here as well. My favorite image of all time is this. I don't know what it is or where I got it from, but it looks good when I say live demo, when I see that. So We are going to switch to a terminal window. We have 25 minutes. So this is Snyk app, right? And you can see here that I've got two different repos, one called Goof and the other one called Snyk Boot web app. And that's the app that we're going to be running from. So what I'm going to do, the first thing I'm going to do is, as a business, I've decided that all my repos need to be scanned, right? And so I'm going to import it into Snyk app. And there's many different ways to import. The simplest way is to use the web, Snyk app web, which is what we're looking at now. But you can import through an API. You can do import projects using the CLI. So there's many different ways. So I am connected to GitHub itself. So with this app, what I'm going to do is say add project. I'm going to select GitHub. Now, as part of the integration, when I connected to GitHub, I had to give it a personal access token. And once I did that, I was able to see all the different organizations and repos that I have access to. So I'm going to search for Spring Boot Web App. I'm going to tell you what it does, and then we're going to switch to an IDE. So I'm going to import this. The little tick tells me it's already been imported. So why would I want to import a repo? So what I'm going to do is just switch to here. When I'm importing a repo, I want to look at all the different artifacts that are in there. Remember I said that the developer now has far more ownership than he had before. So I want to scan any of the open source manifest files. In this case, it's a Java app, so I chose to use Maven, so there's a pom.xml in there, so it scanned that, right? But there's actually more than those files in there. So you can see here that it just scanned all this a few seconds ago. I found a couple, there's an Argo CD directory, so I found some Kubernetes YAML files, and they're scanned as an IAC file, so we'll get a viewpoint of what our security config looks like from that. It scanned our Docker file as well, so it was able to, from the Docker file, look at the from tag and any user instruction layers and determine what vulnerabilities have come in just from that as well. There's a couple of other Kubernetes YAML files, there's a pom.xml, and there's also a main.tf, which is the Terraform version of the app itself. But as you can see here, what we've done here is enabled all these different types of scan across this app and shown it all in one single viewpoint. And so as a result of that, now we can start focusing on the remediation advice and what we need to fix. So let's start with this pom.xml. And one of the first things you'll see is what we need to do is when we scan the pom.xml, we need to build a dependency tree. So if ever you do a Maven install, for example, or a Maven package, and same thing with Gradle as well, what it does is on the file system build a dependency tree. What I mean by that is, let's say you've got 4 or 5 dependencies declared in your pom.xml. Those dependencies bring other dependencies and other dependencies and other dependencies. It'll build a dependency tree out of that. And then when Snyk scans that, it uses the dependency tree versioning and what we've got in our vulnerability database to tell you exactly what vulnerabilities you have and where as well, right? So if I look at this, the dependency tree has 40 different libraries in there. So if I go here and I select this, you can see here that I'm bringing in this Spring Boot actuator, which is one of my open source dependencies, but the actual vulnerabilities are far deeper than that, right? And so you can see I've got some critical and medium issues somewhere buried within that base dependency, right? The smarts of an open source security scanning capability is to actually go and work out what version I can update to fix not just the base dependency, but potentially the indirect dependencies that have been affected as well. So for this one here, for the sake of the demo itself, I'm going to go back to the Issues tab, and I'm going to type in this log4j issue here, right? So you can see here, this is the classic log4j issue, 0-day vulnerability that came out. The exploit maturity, proof of concept is there, so it's something I need to look at. We also have this concept of a priority score, right? So what that means is we look at various factors. Is there a fix available? Is there a mature exploit? Is it trending on Twitter? All this information helps us to determine whether it's critical, medium, high or low, as well as a CVSS score, of course. So when I spoke about fixing this vulnerability, I could just go into here and say, let's fix this vulnerability. Now, it would do it automatically, but I'm just choosing to manually fix this, for example. And so when I fix this, open up a fix pull request, it's going to start integrating into my source code management system. In this case, it's GitHub. And it's going to fix this as a pull request. I haven't merged it, I haven't done anything at the moment. And it's going to put all that data directly into the pull request. Now, if you have a look at what's happening here is, and you can get all these details from here, is we're upgrading the version of the log4j core library to a later version to be able to fix this log4j remote code execution problem. And if you ever saw this or if you ever researched this, you were vulnerable in terms of how your app was built, but it was pretty critical in terms of people being able to execute code within going through an LDAP sort of path. So it was an issue that a lot of people wanted to fix, right? So I'm not going to fix this issue now. I could, right, but I'm not going to. But ultimately, if I did, that'd be one less security vulnerability for me to look at, right? So hopefully that explains open source and how it works and what it's doing. So what we're going to do now is I'm going to go back into the projects view. I'm going to now switch. This app here is running in IntelliJ as well. Unfortunately, I can make the code bigger, but not the actual window down the bottom. But what you can see here is I've got this little Snyk tab, so I've installed the plugin for Snyk. And as a developer, I can just kick off a scan here. Very similar to what we're doing at the source code management layer. This time I'm scanning the code, the open source manifest, the ISCs, all directly on the file system. So I'm not integrated into Git. And when I do that, I'll get a viewpoint of all these scans here. So you can see here, the pom.xml, there's the log4j issue. You get that same vulnerability advice, the CWE, CVE, all that sort of information is there. The ability to fix it now through a pull request will be different. You'll just be given the remediation advice here. You'll need to go into the pom.xml to change it. Having a look, we've got 17 minutes. But there's a couple of other scans that we do. I'm going to bring these up now because we're going to go through these as well. We do container scans and configuration scans. We're going to deploy this Spring Boot app into Kubernetes, and we're going to do it through Argo. And you can see here I've got a couple of configuration files here. So the container does not drop all default capabilities. If you ever used Linux, you'll know that it's got a bunch of default Linux capabilities. I think over 120 of them. Why you would ever need them to run a stateless app, I don't know. But no one ever turns it off, right? Or maybe some organizations do, but more often than not, they don't. So the whole idea is you can drop all those Linux capabilities. Why would you? If someone gets into your container, they have full Linux capabilities and the ability to do what they need to do. If you drop those Linux capabilities, even though they may get into the container, they don't have those capabilities. So that's what we call an ISC security misconfiguration. The other thing that we've done here is a code scan as well, right? So we've found a SQL injection, so we haven't looked at that yet. But when we look at a SaaS issue in terms of what the security issue looks like from a coding perspective, here what we've found is an SQL injection. But what's important is understanding the flow. How does a user that's on some web page or maybe hitting a REST endpoint make its way into that vulnerable code, and why does it make this a SQL injection, right? So maybe they haven't sanitized it, maybe they allowed arbitrary strings to be able to be executed, which means someone could do drop table, for example. And the data flow is quite important. You want to understand how you got to that, right? You can see here there's a customer REST service and a customer service. The REST is the front end endpoint into the app. The service is where the SQL injection is, right? So I can fix it in one of two places. Ultimately, I need to fix it though. And then as a result of that, we get some example fixes as well. So if I just go up here, we've got the context from an example fixes here. It's not changing it so that you can take that code and exactly put it in, but it's showing you what other people have done. Because with our Snyk code capability, we're scanning multiple, I think over 1,400 different open source repos, the most popular open source repos, lots of contributors, lots of fixes. And we're building our rules engine and we're doing an analysis across them to be able to give you the most relevant fixes, but more importantly, give you the issues you should be focusing on and not false positives, for example, what we call true positives in the SaaS perspective. So hopefully that gives you a feel from the idea. Now what we're going to do is I'm going to switch, so we've got 14 minutes. If you're ever wondering why I keep bringing up the time, I was talking to Igor and he said to me, people have got 45 minutes, 30 minutes, but they never use the whole time. So my aim is to use the whole time, right? So for those that want to leave early, I apologize, right? So what I'm going to do now is I've got these various projects. What I want to do is now just switch to the container itself's already been built. So I'm going to switch to just Docker Hub, right? And you can see here I've got this app, it's containerized and it's been scanned, right? So what happens when we scan, so I've integrated with Docker Hub, I've connected to Docker Hub and I've imported. So I'm going to I'm not going to do the import, it's already been done. But notice here from the scan, I have two different scan types. I have something called V1 and I have something called V1:/app. So what the V1:/app, you could probably see from the icon, one is indicating all the Maven dependencies. I was talking about the open source dependencies. The other one is indicating V1 is the tag of the image, the base image and how many vulnerabilities are in there, right? So if I go to this V1 itself, so two different scans within the same container. It will tell you what the base image is, so that's cool. I had to auto-detect that, right? So it didn't know it. It knew it from the Docker file, but it didn't know it from the container itself. And then it gives you, there's actually two ways. These are all the vulnerabilities in the Linux container. Some of them have no known exploits, so maybe it's not something I need to focus on. But as a developer, or even as a DevOps engineer, do you really want to go and fix all these? How many do we have here? 85, right? So even more, right? So yeah, 86 different types of vulnerabilities. Do you really want to go fix those? The easy way would be okay, so from Snyk's perspective, this is your current image. It's got 86 vulnerabilities. The ones you really care about are the critical ones, maybe high. Can I switch to another base image to be able to actually go and reduce the number of vulnerabilities? You can see here we've got minor, major, or alternative upgrades, right? So inadvertently, the developers don't mean to do this. They just choose a base image that can run their Node app, their Java app, their Python app, whatever it may be. And more often than not, they choose some sort of base image that's popular and they stick with that one. And they may not have updated that base image for a while. Some choose the latest base image. And so here you can see what we're doing is we're giving alternative upgrades. And then as a result of that, we're giving you the viewpoint. If you decided to choose that one, so let's say we choose this OpenJDK 18.02 Slim Buster, I'm only going to have 59 vulnerabilities, but more importantly, so I've cut 30 vulnerabilities, not a lot. I've got 0 critical if I choose that one, right? If I go even further, I'm even going to get less, right? So the last thing that I want to show before we do some other interesting things is when I go to projects here, let's get this out of the way for a sec, and I go to Kubernetes. So I don't have this app running at the moment, but I've got other Kubernetes apps running. So I've got a Juice Shop, Guestbook UI, some other Spring Boot app, and the Snyk monitor itself, which I'll get to a little further. But if I actually was to click on one of these here, and you would see that you get similar to what you're doing with the container scan. I'm going into the container doing an open source scan, and I'm also looking at the base image. But there's one extra thing that you get from a Kubernetes scan. You can see from the Kubernetes here, is when I click on that, not only am I getting all the vulnerabilities like I got before that I showed you in the container image scan, but I'm also getting an IAC scan. And this is quite important. So I spoke about the drop capabilities in terms of having all those Linux capabilities that you don't need. But what about the fact that all containers run as root unless you tell them not to, by default? Every container will have a file system that you can read and write to, unless you tell it not to. If you don't set CPU and memory limits, there are also security issues in terms of like taking down your app as well, right? So there are all these things that we're already highlighting here so you can fix it. So what I'm going to do is I'm going to switch to the CLI. Now this might be, is that good or do we need it a bit bigger? Bit bigger? One more? Yeah. So while we're there, we'll do 2 more there. Right, so hopefully I'm connected to Argo here. So what I'm going to do here is I'm going to deploy this app. We haven't deployed it yet, right? So I'm using Argo CD to deploy it. I'm pointing it to my Git repo, and in that Git repo has an Argo CD directory that has the deployment files for the app to deploy, right? So if I do that. Now, there's something extra that's happening here. So let's have a look at what it is. So if I go into this Argo CD directory itself and I look at this, I can see that this is the app and how it's going to deploy, but there's also this Snyk IAC scan. Let me just get rid of that. And so as part of this Argo CD deployment, I am authenticating with Snyk and I'm going to do a scan across that YAML file, which is the IAC file itself, right? So if I was to go to here and do this here, if I was to do this, it would give me, if I actually check that file here and run a Snyk IAC test, all it's doing is running this, right? Now, when it runs this, it's going to give me all the misconfigurations that I showed you that you already saw in the Kubernetes cluster, right? And as a result of that, I can block a build here. So you can see here there's containers running without privilege escalation control. The container has no CPU limit. There's no liveness probe. There's all these different problems that we need to fix. And so what we're doing is within this Argo CD deployment is we're running all those tests. Now, I'm not blocking because I want the app to deploy, right? So if I go back to here and go into here, you'll see now that the Spring Boot web app has appeared. This one might need to be a bit bigger. You can see here there's all these different phases to deploy this app in Argo CD, but notice how I ran a job in there, and that job is where it ran my Snyk test itself. So I could block here. I'm not, because if you have a look at what I did here, is every time I run the Snyk IAC or container test scan, I pipe it to true, right? What that's telling me is send an exit status code that's not a failure so I can continue, right? If I didn't do the true, that Argo CD job would not have passed and it wouldn't have deployed the app, right? So, and that is all available in Argo CD here. If I go under logs, you can see here that's the result of the scan that's actually running, right? So the other thing you haven't seen is when you run a CLI scan for a container. So I'll quickly show that as well here. Oops, let's just do that. How are we going for time? 7 minutes. Cat. I think it's scan. So I'm just going to scan the version 1 of the app. So I'm going to let that run. It's going to do the scan, but you'll see how it gives us the base image remediation. Let's just go and see whether or not inside here, whether or not it's deployed our, scanned our app automatically, right? So, and it has, right? You can see here, this didn't exist before. Spring Boot Web Argo CD is what it's called, right? So you can see here, all done. This is version 1 of the app, so it's going to have the same base. It's going to have the same open source issues that we have, and it's going to have to do the same base scan of the container itself. But then also, if we look at this one here, we didn't do any of these fixes here. So how about we do those fixes? We're going to do 2 different types of fixes. So the first one that we're going to do here is, I'm going to go back to this, I'm going to go to there, I'm going to have a look at what the base image is, and we're going to see which one we can fix it to. So how about we go and remove all these critical vulnerabilities, and we use the OpenJDK 20 Slim Buster, right? So we know it's going to be a similar type of image, but less vulnerabilities, at least 30. So we need to go into here. Just move this up a bit. So terminal window somewhere here. So I've got this thing called build container, and I'm just going to say tag it as V2. But if I have a look at the Docker file, you can see here I'm asking it to use the new base image, right? You can see I've commented out the old image itself. So I'm just going to run that. Anyone seen a demo where someone creates a container will know that it takes normally 5 minutes or longer. The reason this one doesn't take 5 minutes is I've run it about 7 million times, right? So now it's created a V2 of the app, which is cool. As you know, when you create a container, there's all these different layers in terms of what the container needs to do. So if none of those layers have changed, then you're only just using a new base image, it can update it really, really quickly. So that's been done. So what we now want to really do is we want to roll out another deployment. Now, instead of using Argo CD, let's just go back to using classic Kubernetes, right? So this time I'm going to run this same app with security fixes. What does that look like? So let's look at that in terms of what the security fixes look like. You can see here, if you want a more secure Kubernetes application in terms of what the IAC config looks like, you will know if you've used Kubernetes enough, you need a security context object, right? So you don't have that, then you're going to fail all these. So I've got one now. I've turned off the privilege escalation. I've made false. Run as root, I've said run as non-root, sorry, is true. I've picked the user to run as. I've set the file system, the read-only file system to true, so you can't even write to it if you got in. And I've dropped all the Linux capabilities. Those will give me a more successful IAC config. So if I just do I can now run that. This is basically just a kubectl, right? So 7. I'm deploying another app, so get pods. It's in this namespace called pairs. If you ever see me do demos, every Kubernetes namespace is named after a fruit. So we have Argo CD, which is the Snyk Boot web one, and then we have this other one here, right? So And one of the things we can do here is the monitor itself. You can actually just tail the logs of it, right? So I say /monitor. So I'm tailing the logs of the monitor, but the reason I'm doing that is I want to see how it's auto-imported, right? So this monitor is looking for new workloads, and this is a new workload. I deployed a totally independent app as far as Kubernetes is concerned, right? So if I go back, we have 3 minutes. If I go back to here. So you'll notice now there's the Spring Boot Web Argo CD, and then there's this other one here, right? So which should be the V2 version of the app, right? And so if I click on this time, I've gone and fixed all my ISC issues. They've all passed because I set it properly security context. But the one that I wanted to show was, I've chosen a new base image as well. So if we go to that, Snyk Boot Web, we actually select the base image. The log4j issue is still there. We fixed it, but we didn't merge it, right? So you can see now I'm now using the 59. Ultimately, what I really want to do is go to these other base images, and then I'll only have low vulnerabilities. But ultimately, I very rarely do I see a base image that has 0 vulnerabilities, right? So, but ultimately, the low ones aren't going to be, the mature exploit won't exist. So the likelihood of them impacting you isn't important. But the other thing that comes up a lot is I've got all these vulnerabilities that are there in my container. I want to know whether or not there's some process that potentially could be getting to that vulnerable library, if you like. So if not, should I really be fixing it? And the only way we can do that is by getting context at runtime in Kubernetes to understand whether or not that library is being loaded, and potentially someone can go through that, right? But ultimately, from a developer perspective, we just want to choose the most appropriate base image that will still run our app with the least amount of vulnerabilities. So from Snyk's perspective, what we want to do is be able to cross all the different DevOps integration points, give the developers the ability to fix all these issues and work with the security team. And really what we're doing there is adding a frictionless experience. It's a buzzword, but it's true. If the developers and the security team can work together, they're going to end up with far more secure apps and a better outcome for the business, right? And so you need the right AppSec tooling to do that. Without it, the developers will not embrace security. 58 seconds. I think the guys will be okay if I finish maybe 30 seconds. Come and visit us at our booth if you want to know more information. So we're working with lots of customers here in New Zealand and Australia as well, right? So thank you very much for your time.